Hey, good evening. Charlie Hill here, Chief Product Officer at Harbor, and I'll start by saying my lighting is not great intentionally. I'm going to be doing some nighttime IR LED testing, and much like my other videos, I don't have a teleprompter. I'm just kind of going off of notes here, but this may not be a super polished video. What do I mean by IR? I mean infrared, that is light that is just beyond the visible spectrum. Most IR LEDs are actually somewhat visible, so they're near infrared. Baby monitors utilize these to be able to see in the dark. And most baby monitors and most security cameras, any camera that needs to see in the dark, typically use a variant that is of 850 nanometers, and that is the wavelength. And you'll understand exactly what I'm talking about here in a second, because I'm literally going to show you what this looks like on a chart. And then Harbor uses a wavelength of 940 nanometers. So this is slightly harder to perceive by the human eye. It is less efficient at going through the human eye to the retina. The trade-off is that 940 nanometers is also harder for image sensors like the one in the Harbor camera and other baby monitors, other security cameras to perceive. It's much easier for them to see the 850 nanometer wavelength. So that means that it's harder for Harbor to provide a high quality nighttime image. That being said, during the R&D process, after founding the company, we did that with intention. So we selected specific components, specifically the lens, the image sensor, and the processor, the system on chip, also known as an SoC, to be able to counter that and still provide a high quality nighttime image. Related to that, and out of transparency, we are going through a round of nighttime image quality tuning. I will say that if positioned correctly, we are on par, if not better, than other systems out there. So something that we are working on improving is being somewhat sensitive to positioning. So if you have it mounted on a wall and there's a lot of the wall in view by the camera, sometimes that wall will reflect back the IR LED light, even though we broadcast much, much less than other cameras out there. Sometimes that will drown out the intended target of view, which is your little one. In a similar fashion, if you have it mounted on a dresser and there's a lot of the dresser in view by the camera, same thing. Sometimes the infrared light will reflect back. So just, typically it's just a matter of like turning the head up a little bit, adjusting the positioning, and then boom, you have a solid nighttime image. If positioned correctly, you typically at somewhere between 3 to 6 feet, you can typically see the rise and fall of the chest of your little one. You can see details in their clothing, in the fold of their clothing and the fold of the sheets. Whereas with other systems, it just appears very bright, but washed out. Okay, I'm about to get into the testing of the devices. One thing that I want to make extremely clear is that all of these cameras are presumably well within safety standards for infrared light and broadcasting that at the human eye. That being said, there is research that has been conducted that shows that high intensity, much, much, much higher intensity than any of these cameras put out, can impact human eye health. Additionally, there is research that shows that any light, including infrared light, can impact sleep quality. There's also research that shows that no, infrared light actually improves sleep quality. So you have to take that for what it's worth. The reason we developed it with the 940 nanometer LEDs, and only 2 of them, and we only utilize them at a very low intensity, only a fraction of what they're actually capable of putting out in terms of light intensity, is because I believe that the research in this area is essentially non-existent. So this is an area that should be researched. It's not within my capability to do so, but light is light. And if you are going to tell me that my children, who slept, both of them, with their eyes partially open, shining infrared light at them, which is somewhat visible, on their developing eyes, and you're shining it on them for 2 years straight at a low intensity, if you're going to tell me that that is not going to impact their eye health for 2 years, it's not going to impact them, I just can't get behind that. Now, can we get away from it completely? Probably not. That being said, Harbor was designed, the components were selected so that one day the IR LEDs could be just completely off and you would still have a nighttime image. At the very least, it would detect whenever you're viewing the feed or when motion is happening or whenever the feed needs to pick up something with greater detail and then turn on the infrared LED. But it is something that we developed the camera with the intent of being able to do that one day. All right, what are we testing here today? We have the Harbor camera. Test that first. Then we have the Hubble camera. The Hubble was I think the only, maybe one of the only systems that offered both a monitor and a mobile application when we first started. That being said, we did try it. I don't want to be disparaging of the company. I think there's some things they do right. Obviously, I think that there's a lot of things that they can improve on. The Infant Optics, I really wanted to test this tonight. I don't want to not do the video but I am missing the power cord. It has like an uncommon power adapter. I have it coming tomorrow. That being said, I don't think it's really important to test because I'll tell you what, I'll put it in the comments of what the results ended up being, but the fact that, like, if you compare this to the Hubble camera, the Hubble camera has the same amount of IR LEDs, but at least it's behind an IR screen, whereas the Infinite Optics, all the IR LEDs are exposed. This is a visual LED for, I think, like indications, but you have 1, 2, 3, 4, 5, 6, 7, 8, 9. One of these may be like ambient light sensor. Probably these are like 850 nanometer IR LEDs. But the fact that they're not even behind a screen, it's a lot. The Owlet, the customer that sent this back to us, we offer trade-ins. They did not send back the base. I actually really enjoy the Owlet industrial design. It's what I used whenever my child was, before Harbor. So I do think, also I think on their image quality, they do a lot right. So that being said, you'll see why they have the benefit of a lot of light. And then same thing, because I don't have them sitting on a nice base, but I didn't have the flex stand. Sorry, I also should say what sensor I'm using. This is called the Torchbearer. It is something that I found on Amazon. I think it's pretty good. Like, I actually have a decent amount of experience in this space. I used to do agricultural spectrogram readings, but back when I was in college and the equipment instead of this size was, I don't know, 50 times this size, and you carried it in a backpack. So anybody can do this. Like, I mean, it's not that expensive of a device. That being said, I will also say this is not super high end. I do think that the data that it provides is reliable. I mean, just looking at them, like, yep, that looks correct based upon what I know is inside of the Harbor device. Also, just my experience in this space. So, like, I look at it like that graph looks correct. Okay, this is the Harbor camera. As you can tell, we use 2 IR LEDs. I know that you can't see the lens, but they're on either side of the lens, and we use them at a very low intensity of their total capability. And they are 940 nanometers, as discussed previously. You should be seeing on the side now the spectrogram readings. I am not adjusting the recording camera position or the sensor that's picking up that data. And each camera will have the same location, which is approximately 1 foot away from the recording devices. Okay, this is the Hubble. And as you can tell, they're using 8 IR LEDs. There is a blinking red light down here because it's not paired with its monitor. That should not impact the readings at all. And let's get some readings. So it's worth keeping in mind that the Harbor at peak was at 0.00, that's 2 zeros, 8 watts per square meter per nanometer. Yep, so again, Harbor was at 0.008 watts per square meter per nanometer. The Hubble is showing right now a steady 0.035. So I'll do the math on that later. Okay, this is the Owlet. It has a flashing LED in the middle. That's the pairing LED. I've not set this one up. I'm also holding it with my hand. 0.008 is what Harbor was at. And I can promise you that LED is not going, that flashing LED is not doing that. When I cover up the LED, it drops down to 0.015. Again, we were at 0.008. So when I cover up half their IR LEDs, no, not half, almost half, and that blinking light, it drops down to 0.015. Again, covering it up and some IR LEDs. So right now I've got, 6 IR LEDs partially showing, and right now it's at 0.015. So it just shows like they are using a lot more light. But 10 IR LEDs is essentially what security cameras use, because they have to be able to see like 60 feet at night all the way to the end of the driveway. Okay, this is the Nanit, and let's get to the data recording. Okay, just got a 0.025. Again, it's the exact same distance as all the other devices. 0.025 seems to be holding. 0.025. I'm going to angle up just a little bit just to make sure my device is actively recording. This is okay, and just visibly, right? And you can also see that they're at the 850 nanometer wavelength. Visibly, you can tell the difference, right? I mean, there's a glare. Of the brands that I tested tonight, this is the most perceivably like just red light in your face, and I just am surprised that this has not been a major question of customers before. Maybe it has. Maybe I just haven't been paying attention. Maybe I should search for it, but this is very bright. My eyes are not nighttime adapted, and this is quite bright. So, okay, happy to test other brands that you guys want to recommend or send us. The only light that was in the room, so this lighting that I have around just to record kind of this outro, the monitor wasn't on, my computer wasn't on, this other light behind me wasn't on, or in front of me wasn't on. The only light literally was this Harbor monitor in picture frame mode. By the way, if you haven't used it in picture frame mode, please do. It's amazing to walk past it and see your family when it's not being used as a monitor. Look, I don't want to say that any brand is unsafe. I think that we are the most thoughtfully designed in this space. I think there will be research come out in the years to come saying that infrared light, long-term exposure, we're talking about years, 2, 3, 4 years of exposure at 3 to 6 feet away can cause in some instances challenges for long-term eye health. And this is coming from a father whose 5-year-old wears glasses and has for 2 years, and we wear an eye patch every night. I'm not saying that baby monitors contributed to that, and you guys know which one we used, but I don't know. And I'm sure there were other parenting decisions along the way that could have contributed. Maybe it's just pure genetics. Maybe it's just pure luck. I just want to do the best that I can to mitigate the chance of it not being pure luck for other families. Hopefully this was interesting to you. I definitely do not want to mock or disparage any brands out there. I think that ours is significantly more thoughtfully designed, and we selected components. We intentionally went in with 2 LEDs, and not only that, but we're choosing low intensity IR LEDs, and we're going to select components to where maybe we don't even need the IR LEDs in the future. And I think we have a pretty good image quality, and that image quality will improve over time, I promise you. And we're going to be doing it with significantly less light being pointed at your children. Maybe that won't even matter. Maybe I'm wrong. I don't think I am. Have a good night.